Hey everybody, welcome to today's session, Introduction to Python. We're going to do part 1 in the first hour and part 2 in the second hour. On the screen is a URL, dalemuster.com/python. If you open a browser and go to that URL, you'll end up at the page that I'm showing right here. And folks who are supporting the room, am I coming across okay? Can you give me some feedback?
Yeah, I can hear you great.
Okay.
Does anybody have trouble hearing you? Yep, you're all good, Dale.
Okay. So while you're going to that URL, I want to point out that today's session assumes that you don't know anything about programming or the Python programming language. It does assume that you know how to use a computer. If you have some issues trying to do things that we're doing today, there's help in the room. Make sure you shout out and somebody will give you a hand if you need a hand. It doesn't matter whether you're logged into Mac or Windows. I am curious though, guys in the room, do we have a mix or is everybody on one of the platforms?
We set them all up so that they would be on Mac, but I think a couple people have switched them to Windows, have their own personal computer.
Okay.
So there's both, yes.
People should use whatever they're most comfortable with. Today, the way that I'm set up on the screen, you're seeing me in Mac OS, but now you're seeing me in Windows. So I'm going to be able to switch back and forth between Mac and Windows during the session and show you how to use both of them. So on the Introduction to Python page, you'll see that there are 2 documents that we're going to use today. The first one is Introduction to Python. The next one is Recursion and Python Turtle Graphics. If you click on Introduction to Python, you get this page. And we're not going to go over this in detail, but this is being provided to you in case you leave today and want to continue to work on developing your Python skills. To use Python on your computer, you need to install it. And I have put up here installation guides for Mac OS Python installation, and we're using Python 3. There is a Python 2 that's actually a bit of a different language, but we're using Python 3 today. And if you're using Windows, there is a Windows installation guide here as well. I also want to point out that Python runs on every platform, really, and you can even get an inexpensive Raspberry Pi. That's this board right here. That is a full computer with USB, Ethernet, and memory card ports. This can be even connected to a really inexpensive touch display. And I've listed the parts to put together a full touch computer based on Raspberry Pi parts. This setup with the copy of the operating system on it includes Python. And in this screen here where you see it says programming, you can see it says Python 3 idle, which is what we're using today, is available. And you could create touchscreen applications using Python on a Raspberry Pi platform. There's also a list of tutorials and documentation, along with some full courses on learning Python. And then here is the official Python 3 documentation, where you look up things about the language. And the examples that we're going to be looking at today, I've listed zip files for them here. So this is a document you can come back and access at any time after the session. And right now, while we're here on this page, download these 3 zip files. And I've already done that on my computer, but I'm going to do it again to illustrate it. So my download folder on the Mac is next to the trash can. And if I currently have no downloads, I'm just going to click, and each of those is going into the downloads folder. It would be the same thing on Windows, except it is into the Windows download folder. And then each of these, you should double click or right click extract. We want them extracted into their own folders. And that will give us what we need to start. And support in the room, if you could tell me when everybody seems caught up to this point, and I can continue from here.
Yeah.
How are we doing support?
Oh, we're getting there.
Okay.
Well, it's there. Yeah, they're really strict on that. It's like, yeah, so it's part of my.
I think we're good.
Okay. So before we continue, the view that you're seeing right now is the view out my window. That is the Bay Bridge. I am located in San Francisco, teach for Mizzou from here. This is me, hello. And that's the view out of my window there. Good to see everybody today. I can actually see you in the room with the computer facing your way. Be sure to ask us to slow down or for help as needed. We don't want to rush through this. We want to have a good first experience with programming. So we're going to create our first program. And the first thing that you need to do whenever you're programming is figure out how to use the tools to create a simple program. If you can't write the most simple program, there's no purpose in trying to work on writing a hard program. So on the Mac OS side, if you open up the Finder, so the Finder is the icon here with the face on it, and you go to Applications, we're looking for Python, and here we see in my list Python 3.7, and inside that Python 3.7 folder is idle. This is the integrated development and learning environment for Python. It is a tool for writing and running Python programs. If you double click on idle, it will launch, and we'll see in the bar at the top, it shows idle, and we have the Python shell. If I go over to Windows, and I go to the Start menu, and I go down to P for Python, there's the Python 3.7 folder. Inside the folder is idle again, and if I launch idle, I get this Python shell. So we have the Python shell in Windows, and here we have the Python shell in Mac OS. And it's from here that we're going to write and run our first program. And I need to be sure that everybody is here so that we can move on from there. So how does it look in the room support?
I think I jumped a little bit.
So as people are working that out, I'm going to give the people who have it up the first thing to do, and I'm going to repeat this again so that once everybody's all in the clear and has it up, we'll make sure that everybody can do this. With the idle selected, go to File and select New File. And it would be the same thing in Windows. You'd say File, New File. This is where we're going to write our Python program. And it is the tradition in each programming language for the first program you write to be a hello world program, where all you do is get the program to display the string hello world. So I want you to type in here print, and then in quotes, hello world. And then we're going to save this, and I'm going to choose today to save it on my desktop. You should save it into a folder where you plan to keep your programming projects. And I'm going to call this hello world.py, py for Python. So the extension on Python programs is .py. And so we save this. And then in the menu at the top, there is run, and you say run module, and it brings up the shell, and it executes the program. So we see here it says, in my case, users Dale desktop, which is where my hello world py is. So hello world py is running, and it just displayed what I asked it to, which is hello world. This is our first program. This is our test to see that we can write a simple program and execute it and get the expected output. So support, is everybody got it up?
Does anybody not got it up? Okay, give me just a minute, Dale.
Okay.
I heard a lot of these. Yep, I think we're all good, Dale.
Okay. So I'm going to repeat this again and talk about it a little more this time. So I'm going to select idle, go to File, New File. That's how we create a editor document instance to edit a Python program file. And it is tradition with programming to write a hello world program as your first program. In fact, if I Google here, hello world, we'll see that there's a Wikipedia article on hello world programs. And a hello world program is a computer program that outputs or displays the message hello world. Because it's very simple, it's often used to illustrate the basic syntax of a programming language and is often the first program that those learning to code write, which is why we're doing it. So in this file, we put print, in parentheses, and then in quotes, hello world. This program, before we can run it, needs to be saved. So I'm gonna go to File in idle and say Save As, and choose where I want to save it. So this time I'm going to create a folder on my desktop called My Python Programs. And in it, I'm gonna put hello world. This time I'm gonna put a space in the name .py. Once the program is saved, we go to run module, and it will take that program and run it in the Python shell, and we see the output of the program. So if you're successful at doing this, you know that you're able to write and run a Python program. Now, print is a Python function that has the job of taking a string and sending it out to the user in the shell. So where we see hello world is because the print function was asked to display the string hello world. So in programming, strings are things in quotes. They're a series of characters. And functions are like print here that have a name and then parentheses, and they are passed parameters. So in this case, this string is a parameter. So we're saying print hello world. I could on another line put print. This is another line. Exclamation point. I save that. And now I'm displaying two lines. First line is hello world, and the next line, this is another line, exclamation point. And you'll notice that each print puts what is printed on a separate line. So what I want you to do in the next couple of minutes, and it shouldn't take you very long, is create a new program of your own name. So you could say file, new file, and you could even save it right away, even before you put lines in it, file, save as. So I'm gonna save it as, in my case, my name is, in my Python program is Dale Musser .py. So you use your name. And then I want you to print a series of lines that are things about you. So maybe on the first line, you could print your name. And on subsequent lines, print other information. So finish this, like I said, several lines about you, and see that you can run the program and it displays the information that you're being asked to print. If you need help, make sure you ask for it in the room. And right after this, when everybody's synced up, we'll look at our first program that we downloaded from the website, which will be the Object Position Calc program.
Let's do this in camera. Are we all good?
I think we're good, Dale.
Okay. So what I want you to do is take the program that you downloaded called Object Position Calc and open it. So in my case, I'm here in Mac OS and I'm going to Object Position Calc. Now, most computers are not set up so you can double click this and open it in idle. So you really need to open idle and then go File, Open, and find the program that you have downloaded. The other approach to opening it on Mac OS is that you can drag it to the idle icon and it will open it. And if the idle icon is on the bottom bar, you can drag to the idle icon in the bottom bar and it will open it. If idle is not in the bottom bar on Mac OS, you can drag idle down to the bar so that you have it available here at the bottom. And if you have the other programs open, you can close those. The only one we're interested in the moment is the object position calculation. If we're on Windows, we would go File, Open, and in my case, I have a downloads folder here as well with object position calculation. I select it and open it, and I have the lines of code here.
Hey, Dale.
Yes.
How easy would it be for you to increase the resolution just a little bit? Because on the big screens, it's a little bit hard to see the tiny text.
Let me give it a try.
Okay. Let me, here.
I'd say it's more of the text.
Oh, is that a little bit better? I think it's a little bit better.
Yes. It's more of the Python
the IDLE size, I'd say.
Okay.
Yeah,
Let
that's
me
better
do-
enough. Thank you.
That seems pretty good.
Yeah, that's good.
Very good. Okay.
Yes. Thank you. Appreciate it.
Sure. So, are we synced up?
I believe. Anybody need help before we move on real quick? Which file is supposed to open, Dale? Is it the object position calculation?
Yeah.
Is this where we should be? Yes. Right. Oh, yeah, man. You made this game up. You made this game that loud. Yeah, I hate it. Yeah, I gotta be in. Yeah. Okay, we're good, Dale.
Okay. So let's run this program first to see what it does, and then we'll take a look at the lines in the program. So with object position calc py selected, you go to run module, and you'll see it is running in the shell. And it displays this program calculates an object's final position. Enter the object's initial position, and I'm going to put 5.2. And then it asks for the object's initial velocity, and I'm going to put 2.4. And then the object's acceleration, I'm going to put 9.8. And the time that has elapsed, I'm going to put 1.7. And it says the object's final position is 23.441, etc. So the purpose of this program is to get input from the user and use that input to make a calculation. This is a very common task for a computer program. Take input, perform a calculation, generate output. This formula that we're using is a formula from physics that given an initial position, initial velocity, an acceleration, and a time elapsed, we are able to calculate the final position of an object. So let's take a look at the lines of code that do this. Looking now at the .py file, the first line has a pound sign and then it says object position calculation. This is referred to as a comment. In Python, comments begin with a pound sign. In other programming languages, there are different ways to describe a comment in the code. So for example, in C or C++ or C# or Swift, we use // to define a comment. So in Python, it's a pound sign. Comments are ignored by the programming language, by the, in this case, the Python interpreter just ignores any line that begins with a pound sign. So we skip that. It's here so that you can remember what this program is called or what it's for, or put copyright information in, or convey to another programmer what your intent is. So the next line is this print, and it says print, this program calculates the object's final position. And you'll notice down here in the shell, that corresponds to what got printed out. This print statement generated that line, but you'll notice at the end of the string, there's a /n. The /n creates a new line, creates an empty line. And that is why this line right here, right after this line, is empty. This empty line comes from that /n. So we print a line, we print a new line, and then the print itself, as we saw before, puts you on a new line. So this /n is a way of creating an empty line, and it creates a nice separation between a statement of what the program is going to do and then accepting input from the user. Now, this line is interesting because it is using two functions. Print, we said before, is a function, but this uses two functions. One function is put inside another function. So let's focus on what I've highlighted here first, where it says input enter the object's initial position. Input is a function that by itself accepts input from a user. And the string that is supplied to it is the prompt given to the user. That is the string the user sees before they supply the input. So down here where it says enter the object's initial position, that came from that string right there being presented by input. And what input does is it waits for characters from the user until it sees the user has hit enter. And it returns, just like float here is going to return the initial position, input returns a value. So you can think of on the left side of it like in a math expression, it's assigning a value. So this whole line input is going to get input from the user, and the result from input is going to be passed to a function here called float. So I want to take a moment for us to do a little experiment. We want to leave this code here, but we want to go up to idle and say file, new file, and put just value equals input, give me input colon space, just like that. And then after it, I want you to put print value. And we can save this as, I'm going to put it in my Python programs as test.py. This is a little experiment. I want to understand how input works. I want to understand how a variable works here, and I want to see if I can print a value that I've inputted. So once you've done that, you can hit run, and we see it displays, give me input. I'm going to type hello. And then it displays hello because the input that I entered, the hello, is assigned to the variable value, and that value is then printed, which is what we see happening right here. So the input function's job is to display a string, get input from the user until they hit enter, and then return what the user has inputted. And in this case of our test, the result from input, the value returned from input, is being assigned to a variable called value. And variables hold pieces of information. And a variable's piece of information can change. We can cause it to change. It can change because we do some math on it, or we do an operation on it. But it holds state for our program. So we can see the functionality of this. Input's a function. It takes a string. When it's called, that string is displayed. It accepts input from the user. The input from the user is assigned here to the variable value. If we go back to program object position calc, input, the result of that is going into float. Now, the reason this is happening is when we get input from the user, like we did here, and the user types, what we are getting from them is a string. And a string can contain characters that are number characters, or they could be letter characters, or they could be punctuation characters. And if we're going to do math, as we're doing up here, where we're performing a series of additions, multiplications, exponential on this, if we're going to do math, it has to be on number values. It can't be done on strings. So input supplies a string, and then the function float's job is to convert the string into a floating point number. And in computer science, a floating point number is a number with a decimal part. So the output of this input function, what is returned from it, goes into the float as a parameter. And The job of float is to take the string, convert it to a number, and then the output of it is assigned to initial position. So we come back to our test program. If I tried to say, I'm going to modify this and call this value 1 and say value 2 equals value 1 plus 5, we're going to print value 2. The value 1 here is a string because the result of the input from the user typing on the keyboard is going to be a string. This right here is still a string. So I can't add 5 to it because a string and a number can't be added together. So if I try to run this, I'm going to save it first. And I'm going to type the number 6 and hit enter. It says, can only concatenate string, not int to string. And str is short for string. So it says, you can't mix these two things together. But if we take the value we get from input and convert it to a float, by taking the result of input, giving it to a float, and then taking the float and assigning it to a value, so that value 1 here is a float, then we can add 5 to it. So I'm going to save this. Input 6, and it gives me an output of 11, because 6 plus 5 is 11. I'm going to do that again and show you a problem that we'll deal with in the next example. But if I input my name, Dale can't be converted to a float because none of that is representative of a number. So I get an error that says could not convert string to float Dale. So this program only works if we give it a number. So even something like 5.8, add 6 to it, or add 5 to it, and we get 10.8. If I try to do something like, ooh, didn't mean to do that. If like, it looks sort of like a number, but it isn't. 5, 3b. It's also going to say that can't be converted. So only things that are actually convertible to numbers will be converted by float. Anything else will generate an error. So for each of these lines up here, we are asking for input from the user, converting the input to floats, to numbers, and assigning them to variables so that we have an initial position, an initial velocity, an acceleration, a time elapsed, each of these being variables that we can then use to perform the calculation on this line. So the final position equals the initial position plus the initial velocity times the time elapsed times 0.5 times the acceleration times the time elapsed squared. The star 2 is how we take it to a power. And then the final position is used in a print statement. So this is a different version of a print statement than you initially used in Hello World and the program that was about you. Here we see that print can take multiple parameters, comma separated, and it will display each of them. So it's going to take a string that first displays an empty line, that's the /n. Then it's going to display the object's final position is, and actually a space because it separates each of these by a space. And then it's going to display the value in final position. So if we run this program again, knowing what we know about the program, we can observe its behavior. So it displays, this program calculates an object's final position. We can enter the object's initial position because this input is asking for it. 2.1. That was converted to a float and assigned to the initial position. Now it's asking to enter the object's initial velocity. I'm going to put 1.5. That got converted to a float and assigned to initial velocity. Now it's asking for the object's acceleration, say 9.8. That was converted to a float and assigned to acceleration. Now it's asking for the time that has elapsed, say 6.8. That got converted to a float, set to time elapsed. This calculation occurred, and then the final print displayed an empty line. The object's final position is a space, because each one of these has a separator of a space, and then the number that was calculated, which was the final position. So we take input, we perform a calculation, we generate output. Are there any questions from the room support?
Oh.
How parentheses work.
Everyone good?
Yep.
I think we're good.
Okay. I'm
Switching to a slightly different version of audio. Is this still sound okay?
Yeah.
Okay. AirPods only make it an hour at a time.
Let's get multiple pairs.
They're wireless, Dale. Come on. Just buy some Beats, Dale. Come on. They're way better.
I created them.
Yeah.
Yeah, we're gonna switch this audio things to AirPods.
Oh. Dude, I was never just like photo on them.
Oh yeah. I've never seen them.
Also, my favorite kid was actually I don't know how to do parentheses at all. It's I Twitter like close the parentheses on the input function. That's often something like it's like I create parentheses like
We're all learning. It's okay.
no, I'm saying it's hygiene. I'm just like I was not looking carefully enough.
Yeah.
I'm so cocky.
Oh yeah. This would probably be something.
You think so, man?
Yeah, okay.
You can go to like go to certain like places, right? Certain like times, sessions.
Yeah, you can if you
don't
want to
have
go
to
to
know.
another session, yeah, you can just go to another session.
Okay.
Yeah, absolutely.
Yeah, you're
That's Dale's prerogative. He wants to take like a 5 minute. What's he doing? What are they doing right now? Okay. Yeah, what time is it? Okay, yeah. We did start a little late though.
yeah.
So we'll do like yeah. Yeah.
Someone, people advertising TigerTalks on my web networks. I thought I heard him saying you have to go the entire thing. I'm like, yeah, it was no sense. No, no, I could have wrong, obviously. Yeah. I'm not. I don't hear critically. I'm just.
Well, I got pointed out. Why?
Nothing. Gossiping was. Oh. Oh.
That's us.
Dale, you still there?
No, we're just gonna walk in circles.
Oh,
Oh.
okay.
Oh,
Hey.
So, can you hear me now?
Yes, but just
Very barely.
Give me a sec. So Zoom completely froze on me in the middle.
oh yeah, we're gonna absolutely. We did start a little bit late. So probably won't be right.
try talking.
Yeah, hold on a second. I'm connecting devices back up.
Okay.
Oh, the latency.
Test 1 2. Test 1 2. How's audio level now?
It's pretty good.
Everyone can hear.
Yep.
It's a slight robot, but.
Okay, so where did you lose me?
I'm gonna say like a minute ago.
Did I give the thing about doing the sales tax thing?
No.
No. Okay. So there was quite a bit off. Hold on a second.
Oof.
Oh, we just couldn't hear him.
So, yeah.
Wait, what was he doing?
Okay.
Couldn't hear him because it's audio.
I'm going to fix the audio situation right after I give this next thing.
Okay.
I'm not sure why Zoom lost its mind, but it did.
Okay.
So,
Real quick, Dale. After we do the sales tax, while you fix the audio, we're going to take like a quick 5 to 10 minute break to let people switch out if they want to go to another talk and just breathe for a little bit, if that's good with you.
yeah, well, why don't we do that now then?
Okay.
Oh.
Do the little break because we're at 55,
Okay.
and then we'll come back right after that.
Okay. Sounds good.
Okay.
All right, guys, take a little break. Go grab some water. Go to another talk if you want to, or if you want to keep working. We'll
Hey,
walk around
Dale.
and help you, but-
Yeah.
Look how official I am, baby. I'm so
Oh, wow.
By the way, I need a whole new class that had to use parentheses because I totally forgot to look at the closing parentheses on someone's code.
Are you serious?
There's a syntax there. I'm like, oh, hey. Good break, good break.
So let's see here.
Yeah.
Most of the videos I know.
Oh,
So how is the audio now? Test 1 2. Test 1 2. Can you hear me? Test 1 2. Can you hear me?
I have picked up.
Yeah, so there's another section.
Test 1 2 3 4 5 6.
The issue just like
And then after quarantine trees,
it's nice to have someone who's going to give you feedback and tell you to make that maybe more simpler, easier for you. But personally, actually, do you have Discord? Okay, have you used it for a bit? So Discord is like a free, it's like Skype, but it's free, it's a lot better.
Yeah.
I don't think you're TeamSpeak before.
Yeah.
Okay. Originally it was for gamers, but I'm not going to use it now. But there's one called Python, which is it's a whole server. We're doing that right now. So basically, it's like
yeah, it's a good refresh.
Python. You can go to the
No,
help
yeah.
channel and picture code in there, and it will help you out. And they give like awesome resources. You can ask them questions. So I would check it out. I can definitely. Yeah.
Yeah, because like I checked out, I haven't gone on it in a long time, but I checked out Weekly.
Yeah.
I checked it out and I was like, holy cow. I thought some of them were too bad. They really take off on it. And then I was like, YouTube service. Just really, I was like, I don't like this courses. I'm taking something else I'll be back in a lot. I keep forgetting this isn't here. I just stopped leaving my wallet.
It seems like a lot of politics theory.
And it's not practical.
So I would recommend is what I'm taking right now. I'm actually taking this assignments or stuff here. So it's a kind of custom. I meant to explain it because it's a custom course. So you can't choose what you want to learn. So that means so we might be students online right now. We also find out one of my friends. So you should use like kind of email him like what language you like to learn and what you'd like to be used for. Like for me, I'm gonna be focusing on my major on information security.
Okay.
So I kind of like I was like, hey, I like to kind of learn how to Python a sense of information security. So I believe kind of down the road we'll have focus. I mean, as soon as it's at the semester, that we'll kind of end it with I'm also hoping to use also at the second level as well.
Yeah.
But yes, I assume you're yeah, so these speaking advisors asked me for taking a Python online course. It's called Problems in Computer Science.
Okay.
I don't quite remember exactly what the names. And so she'll give you like a permission number, and then just type that in as you go for it. And then you can choose how many hours you want to do. Standard free. Absolutely. So I'm gonna write down a few online sources I have for grade 2.
Okay, awesome. Thank you. Appreciate it.
No problem. They're actually for all languages.
Yeah, that's awesome.
Also should as well. Like
Using the head for TigerTalks.
just kind of know. So yes, discord.gg is okay. And then the tutorials points.
Yeah, I've heard of these.
Okay, you heard those.
Well, I took
But yeah.
Oh,
I actually thought that the program is a lot like
Yeah,
the one
they're
we had last time.
Oh yeah, I just came across
From when we both went
I was on that rabbit hole. This guy is like cuckoo for Cocoa Puffs for was it Lambda schools?
Okay.
I mean, it's more like an online university thing.
Yeah.
It's like I don't really trust those too much. But
Online
I mean, in
university.
theory, I mean, if it's a credible university, it's just online for them.
I use kind of like look online, like
Yeah.
is from the university is like good, incredible. And usually it's like top research. If they're like being talked down, top to you, people getting the reviews.
Yeah.
Then usually it's pretty good. So yeah. So
But there's just all kinds. I was just looking like which one's good.
Who's that?
Yeah.
There's also so you can also do, I'm sure you have your like export dummies. Like
Yeah, for sure.
It is my library actually.
Yeah.
Let's figure out how far they go.
That's awesome.
Oh, okay. Yes, I think this is, looks like it's a free one. It's called Automate Reporting Stuff. So, because I mean, I don't know if you are aware of like what Python's usually.
No, like I've taken some courses like Python, but see, that's another thing, especially most of around here in Mizzou, where you got a little bit into it. But even most of the courses, I don't know. I guess like for web dev, it was nice. I have to take the second one, yes. I would probably be able to do that. And that's one of the only ones so far that I've taken that actually. We're actually gonna make web pages. Yeah. Like, especially in Python, when you learn basic syntax. I mean, I guess it's cool and like.
Let's read about Python. Wait,
Yeah.
and you're aware of those. It's great for more reusability. It's just great for really anything. So that's why Python's the strongest language for
Really?
security. Yeah, so that's like most people like it was used like Linux terminal things, but Python is, I mean, that's a little more difficult, really. But so the Python's like the strongest one right now. It's actually the most paid right now. Really? So right behind that stops. Yeah, triple digits. Yeah. So, but of course that's not true. But yeah, no, it's just something which I had no experience with this semester.
Okay.
So as soon as he said object position, I'm like, that's what he did. So.
Hey. Well, awesome. Yeah, another thing I wish we do is just like, it just sucks because the higher level courses, there's so many free regs. It's just like, you gotta waste time.
Well, what I like about what Mizzou does really well is actually our CS department is accredited.
Yeah.
What's as I'm sure a lot of people agree, compared to most schools, Mizzou is one of those few schools that they don't just they just don't teach you. They teach you how to actually do this.
Yeah. Okay.
And that's the strong suit. So really, yeah, it is a lot of these high levels and. I'm sure you're aware of like what's your major right now? IT. So, what year are you in right now?
I guess junior.
Okay.
But even though like I still haven't taken like cybersecurity and all.
Oh, that's
And I was going to take just a couple more.
Well, 1050, 2050.
Yeah,
So that's
absolutely. Yeah. No, I took 2050.
I dropped out after a few weeks. It almost pretty well. Yeah.
Well, I think he's too smart. Like, I just don't think he can like, relate. Yeah.
It's just, you got voice. I'm like, so.
He's just he relates too high. Yeah.
Yeah. I think that's more over him. And you can't really do much. I'm pretty sure it's like a lot of smart. That's why
I bet he does.
Yeah.
I bet he does.
But hey, that's a lot. Yeah. So. I don't know if you're aware of this recording. Which you can see.
I mean, I just like one of the base languages, I guess.
It's a really good reason why I do it. It's like really everything. Much rather everything you understand. I think it's kind of key. So C is one of those parts.
Yeah.
And it heavily teaches that implementations. And so that's why they actually teach that first. And that way we learn which is awesome. So now, yeah, now that can be controversial a bit.
All right.
You know,
Dale, you ready for us?
Can you hear me okay?
Yep.
Oh, perfect.
Okay. Or
I started going good side again.
Are we down here still?
Ready whenever you are, Dale.
okay. So given what we've seen with the object position calculation program, I'd like you to give your own attempt at a program that calculates sales tax. So what I want you to do is write a program that calculates the total cost of a product with sales tax. And let's just assume that the tax rate is 6%, so 0.06. So here are your requirements. Write a program called tax.py, and it is to ask the user for the price of a product, calculate the sales tax, calculate the total cost of the product, and then display the original price, the sales tax amount, and the total cost of the product with sales tax. So you're going to use the same method of getting input, converting it to a float to get the initial price of the product, and then after that it is a bit of math and some output. So take the next couple of minutes and see if you can write the sales tax program. Ask for help if you need it.
Okay, because I want to make sure I can see it. Yeah. Why is that sales tax? I can keep up with the number. Oh, we typed it out. Okay. So sales sign. Oh, right now here, calculate sales tax. Oh, and then total cost. Total cost of product. Just feel free to use this one. It's a hard time after feel free to use it if you use this if you want, but I went ahead and typed out the whole thing already, so he has a reference. So I got it. Yeah, no problem. And then Okay. Yeah. Wait. At first I thought it's oh, it's product. Oh, so you underscore. That's just like or you can do sales capital T. Okay, so then sales tax amount is real quick. Obviously, I don't see oh yeah. Real quick, give me 1 second. I don't know whether there was a Python class offered inside that. Really? So that way I wouldn't have to think about yes. One second. Okay, so I got 3. So that will so now for so so yeah. So I'm sure you can hear everything now. Yeah. And for this one, I'm going to say 2. Oh,
So here's the
so my calculator just in case. So so run the program again and begin like 750. Okay, like yes, so I'm gonna fix that. So we're gonna do oh no, so we're gonna do this. So we're gonna do this. So, so now you're going to ground it to decimal places and now save it. And run it again.
Okay, so that was the one thing I was missing.
Oh, yeah, you're good.
I guess that was the one thing I was missing.
Yeah.
Okay, so I was on the right side.
No, yeah, you were all fine. I was going to help fix that in general. So,
Hey,
Dale.
Yeah, what can I do?
Do you want to kind of explain how to use like the rounding function for like the sales tax? Because if someone types in 750, they'll get like 0.44999 repeating.
Yeah. Actually, it's more about, I think, formatting the output, which we're not going to do today, but I can mention it.
Okay, yeah. I just thought of that as well. So
yeah,
that sounds good.
How are we kind of?
Yeah, you were all correct. Yeah, I was kind of a little apology.
So what I'd like to actually do is transition to showing a solution, and then we'll move on, regardless of kind of where people are, just based on time.
Wait, can you repeat that, Dale?
Yeah, I was gonna move on and show a solution, regardless of where people are, based on time.
Okay, sounds good.
So if we could regather the room's attention. Hey, everybody. We are going to take a look at a solution to the challenge and then look at a few more things before this hour's up. If you were able to finish it, great. If you weren't, it made you aware of the things that you need to pay attention to as you take a look at a solution. And this method of learning programming, I find to be the best method for me, that is to work on challenges, that is work on things that you try to build, and then through the practice of working on that challenge, you learn how to do the programming. So here I'm going to go to idle, file, new file. And right away, I'm going to save this so that I have the file name set up. So I'm going to say file save as, and I'm going to put this on my desktop in my Python programs, and it's going to be called tax.py. So we want to get input from the user asking for the price of the product. That's like using this line right here. So I'm going to say here, price. All right, actually, I'm going to write it as product price equals. And then here for the input, we're going to put product price. So that gives us the product price. Now we need the sales tax. So we can say sales tax equals product price times 0.06. And it's actually a good practice in programming to not hard code values like that. So I could put tax rate as a variable here and make it 0.06. And then down here, I can multiply by the tax rate. And then the total cost would equal the product price plus the sales tax. So then I could print product original cost of product, and then the product price, and then we could print the sales tax and put sales tax. And then finally, total cost. And that was the variable total cost. save it, run it. So if the product price was $1, the original cost of the product, now you'll notice this isn't displaying both zeros, and I'll talk about that for a second. And then it calculated the sales tax of 0.06, added together the two, and we got the 1.06. So you might have seen some repeating decimals, or in the case here, you're got a value, but you're thinking of it as money, so you want 2 decimals. In a float, you're gonna just always have the float presented as a float would, not as a monetary amount. The way that we would change this is using a string formatter, which we're not gonna cover today, but you can decide when you're printing what numbers will look like, how many decimal points are displayed. Also, when we do math, we can do things to round to a certain number of decimal points. And these would all be found within the documentation of the Python functions. So this just gives you an illustration of a fairly traditional computer program that takes input, performs calculations, and generates outputs. So let's move on from there. We can close these windows that we've been working with. We want to keep idle open, or we can reopen idle with the program that we're going to do next. And so what I want to look at is the paint job estimator, which you should have also downloaded at the beginning. I'm going to drag and drop it on idle. You could also do file open and go find it. And this is going to illustrate a little more complexity, and we're not necessarily going to go through every aspect of this program, but I want to use it to illustrate some things that the program you just didn't, so that if you leave here and you want to continue to learn how to program, you have a sense of how some things are done. After this program, we're going to be moving to generating some graphics using Turtle Graphics. So if you're a little bored with the whole user input math thing, hang on for a moment. We're going to finish the class generating some graphics. So here we see a program whose job it is to calculate the cost of doing a paint job. And one of the issues that we ran into in the last program is that when you ask for input from the user can type anything, and you might be wanting a number, but they might be typing something that isn't a number. And in the last program, when we typed something that wasn't a number in a place where we were expecting a number, it caused the program to crash. What this program does is it solves the problem of the user inputting something unexpected. So first, let's run the program, and then we'll talk about how we achieved what we're about to see. So paint job estimator is displaying the line paint job cost estimator, and then it displayed the line, what is the area of wall space in square feet? So that's this float input line, just like we saw before. We get the input, pass it to float, float generates the value. So I'm going to type here something that isn't a number, like my name, and you'll see it says only numerical values are valid. And then it asks, what is the area of wall space in square feet again? And I'm going to put 45.1, and it accepts that. And then it says, what is the price of the paint per gallon? And here again, I could put X, Y, Z. And it's going to say, no, only numerical values are valid. What is the price per gallon? I could put 5.6. And then it performs the calculation. So here is what is happening. I want to walk through just a few of these lines of code here. So let's deal with this first one here, where what is the area of wall space in square feet? Then I entered Dale and it asked for it again. That's this loop right here, and I say loop. Okay, so while is a structure within Python that loops while some condition inside the parentheses is true. So this is an interesting thing here. It says while, and then it always passes true. So this would actually form an infinite loop. And there's got to be a way for us to break out of it, and it's going to be actually using this break statement. So the job here is to just sit here and loop forever unless we tell it to stop looping. So inside this loop, we have to define what is happening in the loop, what this block is. And Python defines a block by indenting. So all of these lines right here are this try, this except, this else, are indented the same amount inside this while true colon. So all of these lines are inside the while loop because they're indented at the same level. So this structure, try, except, else, is the way that we handle exceptions, that is errors that occur. Anything inside of a try, and when I say inside, it's its own indented block. So you'll see these lines are indented inside of the try. That means that this forms a block in the try. And so anything in the try that could cause an error would be caught inside of this except statement. So here where we have the input being passed to float, so float is receiving what the user has inputted. If that input can't be converted to a float, it will throw an exception, which means at the point here where the user types Dale, it says, oh, that can't be done, and try, since we're trying to do this, an exception occurs, and so it leaves where the error occurs and it comes down here to the except block, and it prints only numerical values are valid. So that's where that's coming from. And then inside the except, it does a continue, and continue is how we tell it to continue the loop. So it comes back up again and retries to get the area of the wall. And so it asks, again, what is the area of the wall space? It gets that. I get enter 45.1, which it can accept, and it just will continue with the next set of lines. So if it does get input, it then checks to make sure that the wall area isn't less than or equal to 0. If the wall area is less than or equal to 0, then we also display an error that says the wall area must be a positive value, and we say continue and try again. Let's give that a try here. If we run the program again, and we enter -5.6, it'll say wall areas must be positive. What is the area of the wall? I could say 5.6, and it says okay. So either because an exception occurred, we could come down here and print something and then tell it to try again. Or if the value isn't a value that we like it's less than 0, we can display a message and tell it to continue. If it doesn't do either of these, that is, if either the exception occurs or this doesn't display the positive value message, then it will come down here and do the else and break, which means it will leave here and we have the value and we'll move on to do the next thing. So this structure is a very typical structure for getting input from the user, but constraining that input and also checking for errors before we move on and get the next input. Another thing this program does is it sits the whole thing inside of a while loop, just like this while loop we looked at, with a variable called doEstimate initially set to true. And at the bottom of the program, we ask the user, would you like to do another estimate? If they answer anything other than yes, then we set doEstimate to false. And when it goes up here to loop again, it's just going to find that it is false and it will stop. If on the other hand, the user enters something else like Y, then the do estimate won't be set to false and will come up here and it will loop again, which is why we can say Y here and it will ask for input again. And if we say no, and then it exits. One more thing before we leave, I mentioned that there is a way to round. This math function, math.ceil, gets the ceiling of two values as an integer. So here we perform a division, which leads to a fractional part. This will give us the decimal part, the rounds up the decimal value so that we get an integer, and it'll give us a rounded up, the ceiling value of this. So if it were 5.4, it would round it up to 6. If it were 5.7, it would round it up to 6. And then this print shows the idea of formatting. So here, when the paint cost is displayed, we could say that we want to format the paint cost to have two values after the decimal point, so that if the math leads to really repeating decimals, we'd only see two, just like we'd expect when we are displaying dollar amounts. We want to see two values after the decimal point, like .00 or .01 or dot, in this case here, .98. So those serve as examples if you want to play with writing your own programs to perform calculations. What I'd like to do now is move on to the example of spiral. So find spiral.py and open it in idle. And then I want you to run it. And if support staff in the room can tell me when it looks like people are caught up to having this up, then I'll continue from there.
So basic. So basically, it just draws like a night sky. This is like stars, like 200 stars ran places each time. It's oh wait, hang on. There we go. It's so cute.
I think we're almost there, Dale. Just give us one more
Okay,
minute.
got it.
Hey Dale.
Yeah.
I was close to just putting the speeds like the slowest for my assignment for this. You're so welcome I didn't. It's 200 stars, man. Hey, look at this. It's a cute little moon.
Yeah. All right, I think most everybody just got it up, Dale. If you want to keep going.
Sure. So I did what they were just talking about. I slowed it down so you see it's drawing here now. So this is an example of turtle graphics in the Python programming language. Turtle graphics was invented at MIT as a way to teach children in elementary school originally about computing programming concepts. And now it is used quite frequently as a way to generally draw. And it is like you are driving a little turtle around. So the turtle is that little rectangle or triangle that you see moving. And the turtle has position and direction, and you can tell the turtle how to move. And as the turtle moves, you can have it draw, or you can have it not draw. And so if it moves and it's drawing, then it leaves a trail behind. If you tell it to move without drawing, then it just appears in the new position. So to use turtle graphics, we say at the top of our program, import turtle. And this is in Python language, an external module, Python module. And an external module is the way that we include code that somebody else has written into our program so that we don't have to write all that code again ourselves. So that will give us the turtle graphics ability. And it gives us an instance of a turtle to work with, as we see here. We have turtle. Then we declare here a set of constants. Now, Python doesn't really differentiate for us between variables and constants, but we do use a naming scheme often to indicate that we're wanting a constant as opposed to a variable. A constant is a value we want to set and not have change. It's values that we just use, not values we manipulate. So we've defined here a number of circles, a radius, an angle, and an animation speed. These are things that we can use down in our program. Now the turtle that we've imported here is turtle, and we can think of this in object-oriented terms. This is an object, and objects in programming languages that have object orientation, objects can have methods. That's a function called on the object that manipulates the object. So this turtle has a method called speed, and it's like the functions that we used before, but it's a function called on the object. And the parameter for speed is animation speed. So we're passing it the number 9 here. So we're telling the turtle, as you move, here's how fast we want you to move. Then we do a loop, and this is called a for loop. Before, in the last program, we had a while loop. A while loop continues while a condition is true. A for loop continues until we've reached the end of a set of values. So this for loop says for x in range num circles. So let's take this apart. Range is a function that creates a collection for us, a set of values. And the range of values that are created is based on num circles. So here we have 36. So this is going to run from 0 to 36. So this is going to change one step at a time, going up one at a time in this range of numbers. So we're going to go from 0 up to and including 35. So turtle.circles and turtle.left are inside the for loop. By inside, I mean they're both indented. So we've got the same amount of indentation, which means they're inside the loop, which means each time this loop runs, it will run these two lines. So this line, turtle.circle, will draw a circle wherever the turtle is of size radius, which means of size 100. And then it's going to tell the turtle to turn left by some amount, by an amount of angle. And the angle I chose here is 10. So each time the turtle is going to draw a circle and then turn left 10 degrees. Draw a circle, turn left 10 degrees. Draw a circle, turn left 10 degrees until it's done it a total of 36 times, going from 0 up to 35. So we can see here when we run this again, this happening. We are drawing a circle, turning left 10 degrees, drawing a circle, turning left 10 degrees, drawing a circle, turning left 10 degrees, drawing a circle. Now, if we look at the program, we said we're going to do this 36 times. 36 times, moving 10 degrees, 36 times 10 is 360. There are 360 degrees in a circle, which means we go all the way around 360 degrees, which is why we end up with the full spiral at the end. I'm going to increase my speed to the full speed here again so we can play a bit. I'm going to save that. So you're going to run. Do this over here. Okay, we see it went all the way around. Now I'm going to change the angle to be 5 5 times 36 gets us 180. 180 is not the whole way around, it's half the way around. So if we say save and we run this again, we see there are finer steps in the movement of the angle, but we only are drawing halfway around. If I want the angle to be 5 and I want to go all the way around, how many circles do I have to draw? If I need twice as many of them, I'd need 72 circles. I'm going to say save. I'm going to run this again. So you can do more than you can draw circles, and you can do more than just turn left. You can turn left, you can go right, you can go forward. So if we come back to the website from earlier, and if you don't have that anymore, you can just go to dalemusser.com/Python. So we can come back to here. Recursion and Python turtle graphics is a document that I've provided. So this uses what you just saw here, and an example of something called recursion to create an image. I'm going to talk about that in a moment, but what I want to point out here is that there are a number of examples, each drawing interesting things. Each of these can illustrate how to do different things in the Python programming language. Yep. So here, for example, you see colors being drawn. Here, this is an array in Python, an array of colors, and we're making a random choice out of the color array. And the Python turtle graphics examples are also on this page. So you can see various examples to work with. The examples are something that you can look at while you play, because the next thing you're going to do is draw your own picture. The other thing that we can do is, I'm trying to find where I put the link. Here we go. At the bottom, we have here references, and it has turtle graphics, the third one down. You can see here all of the abilities the turtle has: forward, backward, right, left, circle, which we just used. There's speed, which we just used. And then you can tell it to put up its pen or put down its pen when it's drawing so that it leaves a line behind or doesn't leave a line behind. So I'm going to have you write your own program, but before we do that, I just want to show you how this recursion thing works here. So with recursion, what you are doing is having a program repeatedly call itself. So here we've broken up the program into a main function. So I haven't shown you before how to create a function, but here we have a main function and another function called recursive circles. In the main function, we kick this off by calling recursive circles, and then recursive circles inside of itself calls itself. And it repeatedly calls itself, well, changing some parameter. Like in this case, we're reducing the radius by 5 each time. And we keep on calling ourselves until we meet some condition that causes it to stop calling itself, in which case it ends. And the beauty of it is that it can lead to some very interesting images. And the things that I've just talked about very quickly are fully described here in this document. So I have the code for the program. I then describe how that program works, describe how recursion works, and walk you through the program step by step, and then lead you into other examples. So for now, what I want you to do though is just write your own Python program that uses turtle graphics to draw an image that's interesting to you. And then maybe once you leave today, you can access these documents on recursion and turtle graphics and do something even more interesting. So I'm gonna now pass over to you to write your own turtle graphics program.
You're gonna invade my personal space.
You know, like used to work as functions as a foundation in mind. There's built around across the bar. Flash attached. There's the after. This.
I didn't know you were you signed up for this, or you just
Where's his
like I've had a class here.
oh, there.
Don't observe at me. But still, that was gross. So just kind of save it. Maybe because did you switch to IT and so that one time change it? He teaches the 740 and 2040 classes. I don't wait, is Python even on this computer? Oh, it is on the computer. See, it's already there. My bad. I just saw it. Right there. Yes. So you can take this out. Okay. So I would where did you put that up? No, if you go to Apple. So this gives you more. Okay. Thank you. No problem. It's just going to give you one.
Have you made something?
I was just talking about speed. I try to keep it as slow as I can. Let's see. You can change this. Yeah, that's how you. How do I start on an angle? I think I want to go like down. That's what the plan is. So what you do is so for the program. So you want to do that. So after speed, so right. parentheses, and then you'll go down to parentheses. And then save that. What's the turtle? So it just gets done. Oh, so what do you call myself? It's pretty fun. I run straight lines. You can. I just like definitely so if you do it in the 4, it's going to ever aligned. It's going to do a circle. So it's just like you want to be one space and afterwards. So so basically that's a calendar. So usually it's so unless you wanted to say like which number it's on, so if it's on like if it's on the fifth circle, you want to but otherwise you have so what Chris was saying is for the counter so the range is like some turns and it'll do that circle. And then once you go on the so yeah, and then just invalid. So indentation each one. Now it's I'm trying to get make sure you have this indentation. Yeah, so everything is then if you want to draw a straight line, it's just like you do this. So what is this? So yeah, and then oh, this is a late straight line. So yeah, so that's forward. Yeah, so it's C actually all the commands. And scroll down. Now trades you click on each command. So yeah, you click down. Yep. And then if for some reason it's not working, I would just.
Hey Dale.
Yeah.
Lunchtime is about to start in a few minutes, so.
Yep. We're at the end of the activity.
Oh, okay.
Whenever they're done. Yep.
Okay.
That was the last thing.
Thank you.
You're so great, Dale. I almost called you Python. That's your new name.
That's it.
I enjoy that name. That's a badass name.
Professor Python X. No, I can call you Python 90X. There you go.
There you go. P90X.
Yeah. Let's do it. Let's make it happen. Those TigerTalks, and then we'll just bring headbands, yoga mat. We're going to be playing Python.
So I'm going to sign off, I guess. It was great to meet everybody today.
Yes, thank you, Dave.
To continue to, let me switch over to me. Hey, there we go. See everybody. It's good to see you. Have a great Saturday in Columbia. I'm going to have a great day here in San Francisco.
Come down sometime.
What's that again?
Come down sometime.
Yeah,
come
down sometime.
I was there 2 weeks ago.
Oh.
All right.
Yes, thank you so much, Dale.